there, this is Angie with Angie's Beyond the Lecture, and today's problem covers isotopes. So we know that isotopes are basically different variations of the same element, and they differ by the number of neutrons, which of course would affect the atomic mass of our particular element in question. So we do know that mass or atomic mass is the sum of protons and neutrons. And in this particular case, we're dealing with chlorine. And you'll notice I have two particular notations here. We have the Cl with the 37 superscript, that's isotopic notation. And then we also have chlorine-37, its mass notation. So there are two separate notations that basically represent the same thing. And we just need to know what mass we're dealing with, correct? We know the mass that's represented on the periodic table is like the aggregated average mass of chlorine that's abundant on planet Earth. All right, so this particular isotope we're dealing with is different from what's on the periodic table. I believe the mass on chlorine is roughly 35 or perhaps 35.5. I don't have the table in front of me. And it's sitting next to, it's in group 7, it's sitting next to the, I believe, argon, that's a noble gas. Notice we don't have any charges. Typically, chlorine adds an electron to have a negative charge, but we don't have that here. So all we need to do is go to the periodic table and figure out how many protons we have, and that's identified by the atomic number, typically the bottom number in, it's represented typically on the top on the periodic table. And we know it's 17. It's basically 17 in line. It has 17 protons. If it's neutral, of course, it has 17 electrons. In this particular problem, out of our 4 options, A and B would fit the bill. And then we just need to take protons and neutrons and figure out which one adds up to be 37. And of course, we know that would be option B right here. So I wanted to take a little bit of time and just explain those two notations and go over basically what an isotope is. An isotope is the same element, but it may have more or less neutrons, basically, depending on what you're comparing it to in the line of elements. And some elements have, 2 major isotopes, some have more, just depends on what element you're considering here. Now, if I scroll down here, keep in mind each handout for each particular topic has the actual answer and a little explanation here. And here I put, of course, the atomic number is protons. We have mass number, which is protons and neutrons. And then, of course, breaking it down, we have 17 protons and 20 neutrons. And of course, we always know if there's no charge next to the atom, then we know it's 0. We can assume it's 0. And I'll make that notation up here. Okay, so that would be on top with 0 here, or perhaps a 0 here. You could actually have 17 down here. I left that. And we can do that simply because we can assume it's 17 based on the periodic table. So that's it. Thanks for watching. Hit like and subscribe if you'd like to see more math and science material out on YouTube. That's where I'll be mainly posting that information. And I will also have the handout on my website, which will be in the video description how to get there. Thanks again.